Greetings. Okay, so this is a video on the volume of prisms. In previous videos we've discussed the definition of a prism, and I just want to make some quick points about volume. So the volume of a solid, we think of volume as capacity. So if we filled the shape with water, what would the capacity, how much water could we fit into that shape? And this is a really good diagram here. So this gives a cross section. So the volume of any prism, it must be a prism. The cross section must be the same throughout the shape, is the area of the cross section multiplied by the length. Let's just take a closer look at this. Say for instance we have a cube. Of unit length. So this is going to have a volume of 1 centimeter cubed. And we keep going back. So this now would have a volume of 1 centimeter cubed plus 1 centimeter cubed. Let's go back one more. Let's go back some more again. And let's go back n times. So we're going to have n of these 1 centimeters. So the volume then is going to be the area of the cross section multiplied by n, and we call this n the length. So let's return to our definitions. Volume is measured in cubic units. So an example will be a cubic meter or cubic centimeter. The capacity of a container is the amount of fluid, liquid or gas it holds, measured in milliliters, liters, kiloliters and megaliters. And if you want the conversions for those, I've got a video on conversions. So let's just recap. If we've got a straight line, we can measure that. That's the length. If we want to find the amount of squares in this shape, that is a width of 3 and a length of 4. We can count them 1, 2, 3, 4, and it's not too bad for this shape because there's only 12 of them. Say we have a shape with a side length of 1 billion. It's going to be really laborious to count all the squares, so we can just multiply length times width. Now for area, we're using 3D shape. So we've got length, width, height, volume rather. So it's height, width, length. So here we've just got a unit, say, pretend that is a centimeter. Here we've got a length times a length. So we've got 2 dimensions here, and here we've got 3 dimensions because we need to go back. So the volume of a solid is the amount of space it occupies. So if you can imagine, if you have a bath full of water or a container full of water, and we insert a cube and pushing under, the water which is displaced upwards, that would be equal to the volume. The same is true if we fill a container. The capacity of the container would equal the volume. And there's a really important formula for volume. Volume is equal to A multiplied by L, where A is the area of the cross section and L is the length. Okay, so pause the video and have a go at these questions. Now I'm going to put the answers underneath, and I want you to see if you can get the answers. So this one is 18900 centimeters cubed. The answer to this one, B, is 75 centimeters cubed, and the answer to the C is 60 centimeters cubed. Now pause the video and see if you can get those answers. Okay, so hopefully you've done that now. Now we should be producing a structured vertical solution. So we start off with A multiplied by L. The area of the cross section there is going to be 42 multiplied by 15. This is the cross section, multiplied by the length, which is 30. And we get 118,900 centimeters cubed. So the cross section here is going to be this lovely thing. So the volume is going to be A times L. I'm going to use parentheses, half times 5 times 3, multiplied by the length, which is 10, and that gives us 75 centimeters squared. Now hopefully you've all done C. If you haven't, pause the video, identify the cross section, and then calculate the volume. Okay, so this is going to be the cross section. The cross section is the same through the shape. So if you take a knife and cut there, we're going to get the same cross section. If we don't, you haven't chosen the correct cross section. Okay, so let's write a structured solution which is vertical with all the equal signs lining up. So the volume, I've written area for some strange reason, test, is the area multiplied by the length. So I hope you can all recognize that this is a trapezium. So the area of a trapezium is half the height multiplied by the sum of the parallel sides multiplied by the length. So let's fill this in. We've got half, 3, 6 plus 4 multiplied by 4. So we've got half times 3 times 10 times 4, which is 60 centimeters cubed. So I think that is everything you need to know on volume. A critical component of volume is that you can calculate the area of the cross section. If you don't know the formula for trapeziums, kites, parallelograms, squares, rectangles, you're not going to be able to calculate the volume because the area of those quadrilaterals or triangles needs to be calculated first. Okay, so good luck with your maths.